Nice to meet you.
Hi, nice to meet you.
Hi, nice to meet you.
Hi,
Nice to meet you. Nice to meet you.
Hi, my name's
Hi, my name's Akshay.
Hi, nice to meet you. Nice to meet you.
This is information about
Hi, nice to meet you. Okay.
includes technical and research.
Okay, gotcha. Okay, thank you.
Explain where it is. You have a presentation.
Yes.
Whenever you're ready.
Well, our robot design is actually, we built it from the main EV3 set that comes with like the EV3 set.
Okay.
So this is a manual and we built it based on that, and then we added motors to where we wanted, and we added arms on the motors. And what we also did was we like to use acronym KISS, which is keep it simple, silly. So you like to keep your robot simple so that it's more better. And a unique thing about our robot design is the original set comes with a marble in the back, but we changed it to like a couple of gears, which actually forms wheels, so that it goes perfectly straight.
We use infinite loops for keys, and we also used move tank and move steering extensively. So we used it in almost every mission because it's pretty much needed, and we would just adjust the degrees or rotations to what number we want.
Okay.
We also use jigs like this one and other accessories like this. So our robot would go at the exact angle and direction we wanted. Without the jig, we would be putting the robot freehand, and that wouldn't be as accurate. The missions our robot can perform include door, opening door, search engine, adapt to changing conditions, sports, engagement, and we can do this and this. We can do using the right senses and communicating, learning, and we can bring we can do reverse engineering and apprenticeship.
Okay, so some challenges that we had with the robot was, one was the color sensor, because we couldn't figure out what was the right, can you see from here?
Yeah.
Okay, what the right height was for it to sense the color, sense like red to stop, stop at black, follow green, etc. That was one problem. Another problem is a challenge that we had was we used the pictures on here as a jig,
Okay.
which wasn't very accurate because we messed up our programs a lot. And relating to that, another challenge was sometimes we didn't accurately put it where it was needed. So we made a jig, and now it's more accurate. And kind of what Pranav was saying, we replaced the ball that was here with a wheel because the ball wouldn't allow it to move straight, accurate. So we changed it with the wheel, and it is much more efficient.
Okay, good presentation, thank you. Let's talk about the back wheel again, because again, it seems a lot of teams, they keep the caster wheel back there. Now, how well is that wheel holding up for you guys when you do turns? Because it looks like you have to do a lot of turns, going back and forth doing your missions.
Well, we first had on the gears, there's also this rubber thing that goes on top of it.
Right.
So when it was turning, it was like scraping, and it wouldn't do it properly. But now it's actually really smooth. If you can feel, it's really smooth.
Okay.
So we never had problems turning.
When you run your missions, did you quantify how many points you're gonna get with each mission, each run?
Yeah.
And how did that change your design or your attachments? Meaning, did you go, well, in order to get more points, we have to have something different here? Or did you change your robot because of that?
Yeah, we changed this thing, which is basically like over there, for the pushing it. What would happen is we used to use the motor itself to push it, and so what we would do is we would follow this green line,
Okay,
and then it would stop right there at the black, so that would be perfect for that to push that. But what is now happening was on our first 2 times we tried it, the motor went above it, and so it would get stuck.
okay,
So what we added is, and also if we use this thing, which we use to pulse loops, it would go too far and it would just push it back down.
okay.
So what we had to do is we had to add another piece right here, which pushes it.
So that's an adjustment you made today after your
Yeah.
first couple table runs? And I lost track, how many missions total were you trying to accomplish today?
9 to 10.
And how successful were you though in your table runs so far?
We did about 6 to 7 on the second and third one. Yeah, like 8.
What was harder for you to do? The programming, mechanical building, both, either?
I think the hardest thing was probably the programming because installing the sensors was easy, but actually programming them with the loops
Okay,
was harder than most. We also had to measure to program, and that was kind of tough.
okay. I saw that.
Yeah, that's like I think that's the first run
Okay,
on the paper. It's
eyesight's gone, I can see the lines, but I can't read out the numbers, sorry. Okay, so you've got your programs running, you got it programmed, you got the attachments. Let's just say you guys are going on this date, you got another week or so, or a couple more weeks to do something different. What would you do differently?
I think we would make that program a bit more consistent, and I think we might have a go at community learning, since we're already down there.
Okay,
So which programs have been reliable so far?
The door mission, apprentice, adapting to changes, they were all pretty easy, because they didn't take that much programming.
okay, so you started them off, you don't, doesn't take much to do those. But I see you going down, all the way down to that back end of that table. That's a lot of work to get down there, both in terms of programming and mechanical. Again, there's a lot of points to be gained from there as well. And how's that been reliable for you as well?
How Pranav said, we used the KISS term. That actually helped us go through a lot of these, because now, since it's not like really big, it can go through here, get this, go through all these small spaces.
Okay. What did you have most fun with this year? With these missions?
I think the most fun we had was I think not programming the sports mission, but like seeing if it like works or not. Like that was really fun. Like just watching the robot like throw it in, and if it got in, we got really excited.
Right.
I thought you were saying the most fun part about this was the project.
That's I would have said that, but like in the missions, yeah. In the missions, that was the most fun.
One last, we're out of time, one last question. If you were to change something about your robot, not the robot, but the sensors, the controller itself, what would you change? You could whisper in someone's ear from first, you'd say, hey, make me something like this. What would you push for? More sensor attachments? More powerful motors? Everyone's asking for more powerful
Maybe we
motors.
should like have the light sensor, if once it senses the path that we want, it like makes sure, it takes the same path every single time.
Okay.
To add to what she said, maybe like, the color sensor could go faster when we were using the color sensors.
Okay,
The robot can still keep on going faster?
that's a good point. That'd be a good one, because.
No.
Thank you for your time. Make sure you thank your parents and your coach. Good luck to you.
Thank you.
Thank you for your time.
Sure. Absolutely. Good job.